It's me Sakib from Concepta. We will be solving one problem on conduction, and the problem is mainly yeah. So let's start. The temperature of the air on two sides of the plane all are given 20 degree and 20 and 35. So let's draw it. Here the temperature is given 20, and here the temperature is given 35. So there are two temperatures, and in the question H is constant. It will always stay constant, and the temperature of the surface is 25 on 20 degree Celsius air. For the air, the temperature will be like for this surface, and there is nothing other than this is given. And then they said if we want to reduce the heat transfer per unit area by 75%, we should use K, the value of K, and 24 centimeter layer to be put on this portion, this portion, this portion. We will put 0.24 and K. So first of all, let's find out the initial Q by A. Initial Q by A. We know the temperature differences, right? So let's do it. 35 minus 20, and going through this to this side, it will be 1 by H, and then plus this is the new del x 1 and k1 we don't know, x1 and k1 we don't know, and it is 1 by h, right? H is constant for both, so we have it. And one more thing which is really important over here, that we have these equations, and we also can find out q by a using this part, because 25 is given. So let's write 25 minus 20 is 1 by h, or we can write q by a is equal to 25 minus 20 divided by 1 by 10, or we can better write as 50 watt per meter square, right? So just take this value and plug over here. It's 15 and it's 1 by 10 plus del x 1 by k1 plus 1 by 10, and now we can have del x1 k1 is equal to 0.1, right? So we have this value right now. Then we will go further down below, and in the question, if we want to reduce the heat transfer per unit area by 75%, so here it is written by 75%. So we the 75% will be reduced, and we will have about 25%. So what will be the qa by q1, which is the new one? It will be 25 by 100 into 50. If the question says 75%, we would have just multiplied 75, but by, we have to understand this. So it is 12.5 watt per meter square. So now we have a new q, and we have the whole temperature. So this new q, we can write new is equal to, so if we put insulator over here, there is a possibility of this temperature, this surface temperature may decrease, but this 20 degree of air and this 35 degree of air will never change, so it will stay like the same. And h will also and air temperatures here in question it is written h and air temperatures are constant. There is a possibility the surface temperature may decrease. 1.2 and so the value of k will be 0.2667. Watt plus meter degree. So this is all. Thank you. Just the tricky part over here that everyone will have a problem to understand, সেটা হলো যে আমার যে এই ভ্যালুটা আছে, এই ভ্যালুটা এটা আমার বের করে নিতে হয়েছে, কজ এখানে কোনো কিছু বলা ছিল না। সো এই টেম্পারেচার ডিফারেন্সটা ব্যবহার করে আর এগুলো ব্যবহার করে আমরা এটা বের করছি, দেন এখানে এইটাকে সাবস্টিটিউট করছি, টোটাল রেজিস্ট্যান্সটা আসলে বের করছি। সো টোটাল রেজিস্ট্যান্সটা যদি জানি, এটাকেও আমি ধরছি তখন যে ডিক্রিজ করার পরে, ডিক্রিজ করার আগে আমরা ঘটনাগুলো কি হইতে পারে সেইটা হিসেবে আসলে আমি এই আগের ডেল এক্স ওয়ান অ্যান্ড কে এটা বের করছি। তারপরে একটু আমরা পরে স্টেপে আস্তে আস্তে জাস্ট সলভ করছি। থ্যাংক ইউ।